Hey there, welcome to Pomodoro Joe for Sunday, the 5th of November, 2023. Today we're looking at LeetCode problem. 1535, find the winner of an array game. This is a medium problem. All right, so we're given an integer array of distinct integers and an integer k. So we have an array of integers that are distinct, meaning no repeats, and we have some integer k. A game will be played between the first two elements of the array index 0 and array index 1. In each round of the game, we compare array index 0 with array index 1. The larger integer wins and remains at position 0, and the smaller integer moves to the end of the array. The game ends when an integer wins k consecutive rounds. Return the integer which wins the game. It is guaranteed that there will be a winner of the game. All right, so let's look at example 1. So we have 2, 1, 3, 5, 4, 6, 7, and k is 2. So we need to keep playing the game until one of these numbers wins at least 2 times. So the first comparison is 2 versus 1, so 2 wins. Actually, it shows this down here. All right, so 2 wins 1 time. Stays at index 0. Then it's 2 versus 3. Now 3 wins, so 3 wins 1 time. Stays at index 0. So then 3 versus 5. Now 5 wins 1 time, and it stays at index 0. So each one of these has won 1 time, 2, 3, and 5. Now we go 5 against 4. 5 wins again, so that means 5 has 2 wins, and we end, and the result is 5. Okay, and that's the same thing it shows here. All right, let's see. We have another example, but I think we kind of got this one. All right, so we'll put 25 minutes on the Pomodoro timer, and we will get started. All right, so this one has a couple different ways we could solve it. So this has been a pattern with the last couple problems on LeetCode. It follows this general formula where they give you some process that you could simulate exactly, go through, simulate this process, and find the answer and return it. But that's going to take a lot of time. And there's a better way to do it if we just use a little bit of logic. So let's use a little bit of logic on this one. So we have some array, it's ordered. We have a comparison of 2 elements. The larger of the 2 elements stays at index 0 in this array, and the other element gets moved to the end. Okay, so we keep doing this up until one of the elements wins k comparisons. Now, when we move an element to the end, if it cycles around and comes up against 0 again, it's going to lose again. We already know it's going to lose because we've already done that comparison. So once you have an element that's been compared once and lost, it's always going to lose. It's never going to win again. So once we have that element losing, we don't actually have to move it to the end of the array. We can just ignore this element. We already know it's lost. And once we have an element that wins, it's going to keep winning. It's going to stay at index 0 until it loses, and it gets replaced by a new element that wins. So we don't actually need to keep taking these elements, sticking them at the end of the array, and cycling around. We can actually just keep track of what is the winning element now. If there's a new winning element, we'll replace it, and that one will keep being the new winning element until it gets beaten, until it gets replaced by a new element. So let's do this. We'll have some result. We're going to set it to, well, we need something, so we'll start with array at index 0. Just assume that this could be the result. And we'll keep track of what index we're in. So we aren't going to actually keep cycling through here. We're just going to do these comparisons one time, because we only need to check each element once against some other element. Once it loses, it's always going to lose, and we can just throw it out of the array. So we'll just keep track of what index we're on. So we're at index 0. And then we also want to keep track of, let's see, what else do we need? So we also need to keep track of how many rounds this current result has won. Because again, once this element loses, once it loses 1 time, it's going to lose every time because the new element that replaced it will always beat that element, and it will only be compared to the new element or some higher element. So once we lose, we can ignore this element. So we only need to keep track of the current rounds that are being won. So let's see, rounds equals, maybe I'll call it 1 rounds. Winning rounds. So this is how many times this element, the result, has won. All right. And I think that might be all we need. Let's see, we've got our current result, or the current winning element. We have our current index into our array, and we have the number of times this element has won. Maybe I'll call it 1 count or win count. I'll do that, win count. So this is how many times this element has won. Okay, now we just need to go through our array. So how do we go through the array? Well, there are a couple different conditions we need to keep an eye on. One is we don't want to go out of bounds with our index. So let's start with that one. So while our index is less than the length of our array, now we're still in bounds. And the other thing we need to keep an eye on is this win count. We can stop once this win count equals k. So while we still have an index less than our length of the array and win count is less than k, then we'll keep going. Once either of these are true, we're done and we'll end. For now, I'm just going to pass. Let's get down to the end here. So once we get to the end of all of this, we can return our result. Okay, so then what do we do in our loop? Well, let's take a look at our current values. So we have our current result, and we'll compare our current result to our new challenger, we'll call it. So if this result is greater than this new challenger, and that's going to be the array at this index, well then our result remains the winner. So we have a new win count, so our win count increases. And our index will increase. We'll move on to the next element. And I think that's it, and we'll just continue. So we're going to have a new challenger against our current winner, which is our result. If our current result is still greater than this new challenger, then our win count increases by 1, and we move on to the next element. Now, if our result is not greater than our challenger, now we have a new winner. So we have to reset our win count. We still have to advance to the next element, but we also have to reset our result or set our result to this new challenger. So in this case, our result will equal this new challenger, array at index. Our win count gets reset to 1. It's had 1 win so far. We'll still move on to the next element. So index plus equals 1. And I think that's it, actually. Okay, so this is our entire process right here. We don't actually have to do this like move elements to the back. We're just going to keep track of which element is the current winner or the current head of our list at element index 0. And we'll just keep track of which element is the next challenger. All right, while our current winner is still the winner, is greater than our current challenger, we'll increment our win count and go to the next element. If at any point our challenger is the winner, then we have a new winner as our result, the array at this index. We set its win count to 1. It's only had 1 win so far, and we move on to the next element. All right, let's see if this works. We do not work. Let's see, what's wrong here? We've got while our index is less than our array, and while our win count is less than k, we're going to check to see, Oh, here's my problem. I have equals plus 1 instead of plus equals 1. Typing too fast. All right, try that one more time. Still not. Let's see, what do we do wrong? The win count increased by 1, index increased by 1. We'll continue. This is my problem here. So we're not actually starting at index 0. We already set this to 0. Our next challenger is at index 1. Try that one more time. There we go. Okay, off by 1 error. Fairly common. Okay, let's submit this to see how we do. All right, and we do pass. And let's see, we do fairly well. We're beating 62% for runtime and 63% for memory, so that's pretty good. And if we're looking here, we're in this top tier, so I think everybody has a pretty similar algorithm. We can take a look at what other people are doing. Yep, they're doing basically the same thing. Theirs is a little bit shorter because they're going through their range, and I have a little bit of a longer comparison for mine, but it's pretty similar. All right. Let's see, what can we do to speed this up? Well, we could change this. Actually, I'm not even going to try to speed this up. We're already in the top tier. If we do make improvements, they're going to be minor. So we could try one thing really quick. So we're checking if the result is greater than this, and then we'll continue if it's not. We could change this to an else. That's one thing we could try. if, and then else. Now typically this will be slower because it has more branching, but let's see, we can give it a shot. Let's see, it looks like it is a little bit slower. It went from a 62% to a 58%, so it's a little bit slower. The other thing we could do is we could flip these conditionals around. So previously, we're checking if the result is greater than the array at this index, and we'll do this. We could check if the result is less than or equal to the array at this index. Do this, and continue. Let's see here, let's get the tabbing right. And then if it's not, then we'll do this. So this is just basically flipping our conditional around. Now I expect this to be slower because typically doing a less than or equal to is actually going to be slower than doing a greater than. But let's see. Now let's see, I got too much here, gotta get rid of this. All right. And we actually do a little bit better. Wow, that surprises me. So we went from a 62%, then when we got rid of our continue, we went down to a 58%. But when we flipped our conditional, we went to a 67% and a 63% from memory. So this is actually better than my initial solution, which is surprising. All right, well, I think that's it for me. We've kind of exhausted this one, but it's a fun one. It takes a little bit more thinking and a little less programming. So you have to think ahead of time, what's a better way to do this than just simulate the steps that they're giving me? All right, again, this is LeetCode problem 1535. It's a medium problem and it's a fun one. Give it a shot. All right, hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.